Right, welcome back. I'm basically continuing on from the previous video. I just want to address something that I said in the last video, which is that you should only use the n+1 when you've got a list of numbers. Now, that is generally true, but there is a situation where even within the context of using a group table, that you would still use the n+1, and I sort of addressed it in the message in the email, which is where I said, okay, or if it's group data, when you're asked to state the interval in which the median lies. So what I mean is, and it was also in the previous video in the description. So let me just have a look at that. What did I write there? Once you have group data, you don't use n+1 anymore unless it's to state the interval in which either Q1, Q2, or Q3 lies, right? And the point is that that's not the same as estimating the median or the quartiles from a group table. It's not the same thing. So where is the median and where are the quartiles? Okay, so if you've got a list of data, it's what we did in the last video. It's what this thing is all to do with. It's this thing where there are at least two methods that you're aware of, and sometimes they can produce a different answer, but it's, as long as you're consistent, there's not a right and there's not a wrong. So that's what happens if you've got a list of data. Now for grouped data, if I say, where is the median? Where is it? In either example 1 here or example 2. This is not the same thing as estimating the median. I'll get on to estimating in a second. When I'm saying where is it, in that situation, you still want to do the n+1 thing. So if you do 3 add 5, you get 8, add 7 is 15, add another 8 is 23. So there are 23 numbers. 3 of them were either 1 or 2, 5 of them were either 3, 4 or 5, 7 of them were either 6, 7, 8, 9 or 10, and 8 of them were between 11 and 20. We don't know exactly what they were, but we do have this limited information about them, which is why it would be an estimate for the median. But we can say where the median is. If you do 23 and then add 1 is 24 and then halve it, that would be it'll be the 12th number. The 12th number would have been the median. So you could imagine putting all these numbers in order. We're not trying to get an estimate for what the 12th number is. We just want to know where is it. So which class is it in? Which group is it in? Well, it's not in this one, right? Because this is only the first 3. It's not in this one because this would be numbers 4, 5, 6, 7, and 8. It would be in here, right? So this is like back at GCSE, where you just had to state the interval in which the median lies. So it would be in this one because the 12th number would be in that box, right? You've got the first 3 are between 1 and 2. Then the next 5, so far we're up to 8 numbers altogether, and the next 5 are between 3 and 5. And then numbers 9, 10, 11, and 12, 13, 14, and 15 would all be here. And in particular, the 12th number would be in here. So that's where the median lies. It's not an estimate of the median. It's not an estimate of the median. And if I said, okay, where's the first quartile? Well, okay, if you do let's go with the blue method because that's what would want us to do from the book, and it's not going to make any difference anyway because n is not 2 more than a multiple of 4. So if you do 24 divided by 4, it's the 6th number. It's the 6th number. So the first quartile would be in this class here, this group. And so, okay, you run into some issue where sometimes you say it would be halfway between two numbers, and maybe it would be halfway between 2 groups. But again, you could just write that in words. You could say it's halfway between, say it was halfway between the 20th and the 21st. You would say, it could be either in, you would just say that. You would just say it and move on, right? Because if you are asked, where is it? You're not being asked to estimate it. And if we do the same thing over here with EG2, now this is continuous data. If I ask you, where is the median? Where is it? So, okay, here we do 4 add 5 is 9, add 7 is 16, add 10 is 26, 26 add 1 is 27, and half of 27 is 13.5. So we are halfway between the 13th and the 14th number, so we would look to see where are the 13th and 14th number. And the 13th and 14th number are both in this class here, this group here. And so we would just say that this interval here is where the median lies. That's not an estimate for the median. That's not an estimate for the median. And notice, because I was being asked, where is it? I am permitted to use this blue method. I could also just as well have used the equivalent of the red method, right? It's still the situation where I would say, okay, look, there are 26 numbers. Okay, so the median would be halfway between the 13th and the 14th. I mean, that's true for the red and for the blue approach. And then you can have a think about what that would mean in terms of whereabouts it would be. Which class would it be in, right? Because you've got your cumulative frequencies for 9, 16, 26, and you go from there. So that is where you can still use the n+1 formula, okay? It's to do with locating the median and locating the quartiles, right? It's telling you, where do you look? Where do you look? Now, when it comes to estimating the median and estimating the quartiles, if we have a list of data, it's not an estimate. And it's something that we can actually calculate, we can actually work out. And we could use either the blue method or the red method, and most of the time, as I showed you in the previous video, you get the same answer either way, unless you've got 2 more than a multiple of 4 data points, in which case, you've got to pick which one you prefer to use. The only time you'll be asked to actually estimate the median or the quartiles is when you have a group table where you have classes. And it could be discrete, like this, or it could be continuous. Either way, it's going to be an estimate. You've done estimating the mean from a table. It's where you use the midpoint and do frequency times midpoint, add them up, divide. You've estimated the standard deviation as well. How do you estimate the median? And how do you estimate the quartiles? So this is now moving away from this. This is almost not related. This is not related. This is, I have a list of numbers. I have I don't know, 30 numbers. I have 50 numbers. Whereabouts do I look? When I'm being asked to estimate, it's a little bit more complicated, and I have a different strategy to follow, okay? So you do need to be able to estimate the mean. You do need to be able to estimate the standard deviation as well. You also need to be able to estimate the median and estimate the quartiles, and you need to be able to do this for both discrete data and for continuous data. Okay? Now in that situation, the n+1 just won't even enter into it. Won't even enter into it. Okay? Now the easiest way I have to explain how to do this is to show you what to do for continuous data, and then show you how we take a similar method. well, if we can do it for continuous data, then there's just one little thing we need to do to the discrete data before we can basically do the same thing. And I think what I will do is actually do a separate video on that. Okay, so this is going to be a 3-part series. Yeah, so we will do that in the next video. So in the next video, in part 3, we will estimate the median and estimate the quartiles for this group continuous data, and we will also do it for grouped discrete data, and I'll show you what to do in this situation. You know, basically it comes down to either sketching a histogram or sketching a cumulative frequency curve. And here you need to introduce something called a continuity correction. Okay, you basically need to approximate this to be continuous. Instead of it going between 1 to 2, you make it go from, say, 0.5 to 2.5. You basically you make the intervals join up. You make it so that there aren't any gaps, and then you basically apply the same process as we'll see in the continuous case. But anyway, I'm going to finish this video here and see you in part 3.